Alright, so let's look at lesson 8.8, perimeter and area. Question number 1, they're asking you to find the perimeter of the green rectangle. You notice that it is less than, each part is less than 1 centimeter. So you have 1/5 of a centimeter and 1/3 of a centimeter. So let me blow that out for you over here. If you're going to draw that, it's like having a box like that, 1/5 centimeter and 1/3 centimeter. So perimeter is distance around an object. So what you're going to do here is just going to add up 1/3 and 1/3 and 1/5 and another 1/3 and another 1/5 to find your perimeter. So you can see I've reordered the add-ends. I have what I have is I have 1/3 and 1/3 over here and 1/5 and 1/5 here. So you add these two up and you'll get 2/3 plus 2/5. You notice those are unlike denominators, so you have to find a common denominator for that. So we went ahead and drew the double rainbow action. So 3 times 5 is 15. So what you do to the bottom, you do to the top. So 2 times 5 is 10. So 2/3 is equivalent to 10/15. And then 5 times 3 is 15, and 2 times 3 is 6. So you end up with 10/15 plus 6/15, which would equal 16/15. And you can see that that is an improper fraction. So that's an improper fraction, so you want to simplify that. 15 will go into 16 one whole time, and there'll be 1/15 left over. So the perimeter of that little tiny rectangle is 1 1/15 centimeters. All right, let's take a look at problem number 2. They're asking what's the difference between finding the perimeter of a rectangle with fractional sides compared to a rectangle with whole number sides. So I'm not sure why they're asking this. It's basically the same thing with just different numbers. Either one, if you add up 2 and 3 and 2 and 3, or you add up fractional sides like 2.5 and 3.5. The only difference is you have to add the fractional element instead of just the whole numbers. So pretty simple problem to that. So what they're asking is, in both cases, you have to add up all sides together to get the perimeter. However, with the fractional side lengths, you use fractions to add those up, and that's the answer to that problem. And here is their explanation, which doesn't really make a bunch of sense, but there's their answer right there. So stop the video and take a look at their thinking, and that should help you understand it. But the question is not the best question I've ever heard. For question number 3, they're asking us to make a correct model to show the area of a rectangle with fractional sides. So just think about that. If you use the simple strategy, just go back to a regular rectangle. If the rectangle is 2 by 1, to find the area you multiply the length times the width, so that would just be 2 here. Same difference here. They're asking you to find the area of fractional sides half. So you can see that this is 1/2 here, and you can also see that this is 3/4 here. So if you overlay those two, I'll use different colors to show you. The red highlights half of the rectangle here, and the green shows 3/4 of this rectangle here. So 1/2 of 3/4 is this area right in here. So this model shows 1/2 of 3/4. This one over here shows 4/4, or the whole thing, times 1/2. So this would not be the correct model. Looking at the answer down here, the model shows that half, this area here, multiplied by 3/4 this area here will produce a rectangle that has 8 parts in it. So 1/2 of 3/4 would be 3 parts of 8 equal parts of a square, or 3/8 of a square. So the area should equal 3/8 square miles. And this is the example, the answer that they show on Think Central. So if you're unclear of how I solved it, you can also study this, but the answer is 3/8. You stop the video and take a look at their thinking. Problem number 4, for the homework assignment, you're asked to find the perimeter and the area. So you're going to find 2 things. Remember, perimeter is distance around in linear units. Area is just the amount of space inside. So you find this by adding up side by side by side by side, and here you find it by multiplying length times width. First, find the perimeter. These are it's a square. It says it's a rectangle, but remember, a square is a rectangle. So we're just going to add up all sides here. So it's 1/2 plus 1/2 plus 1/2 plus 1/2, which gives you 4 halves, which is the same as 2 wholes. So since they're centimeters, it's 2 centimeters. So the perimeter would be 2 centimeters. Alright, to find the area, you multiply the length times the width. It's 1/2 times 1/2, and multiply numerator, numerator, it's 1, denominator times denominator, 4. So the area is 1/4, and remember, it's important to label it correctly. It would be centimeters squared, or square centimeters. And here's the Think Central explanation for the problem. So another way to look at it, stop the video and study this if you need clarification. Same problem type as the last one. They're asking you to find the perimeter and the area of the rectangle. I'm going to go ahead and label all these. Since it's a rectangle, you know that opposite sides are congruent. So 4 and 4, 5 and 5. Now for perimeter, you just add them up. 4 plus 5 plus 4 plus 5, and that would give you 8 plus 10, and that would give you 18 inches. It's a linear measurement, so it's linear, it's just inches. To find the area, you multiply the length times the width, so that's just 4 times 5, and that would give you 20. And you're measuring square units on the inside, so you have to record that in square units. So it's 20 inches squared, or square inches. This page outlines Think Central's breakdown of how you solve this problem. Pause the video and study it if you need to. This next problem, they're just asking you to find the missing side length. So it's fairly simple, other than dividing by decimals. It's a classic area model, so length times width equals area. So if we plug in these numbers here and here, then we can find the width. So I plugged in the numbers 5 and 7/10 meters times unknown meters equals 42 and 18/100 meters squared. So remember, when you want to find this, you use the inverse operation. Instead of multiplying length times width, you divide the area by the length, and that will give you the width. So remember, when you set up your division problem, you don't want to divide by decimals. So instead, you multiply this side by 10, scoop, move it over, and move it up, and now you have your division problem set up without decimal points to worry about. So 57 does not go into 4, 57 does not go into 42, 57 does go into 421. The way I'm going to get my estimate, I'm going to say that 57 is close to 60, so I'm going to use my multiples of 60 or 6, and what number is closest to 420. So I know that 7 times 6 is 42, so 60 times 7 would be 420. So I'm going to try 7 as my first quotient. So I went ahead and multiplied 57 times 7. I ended up with 399. So that works out in this problem. I subtract the 2, and that gives me a difference of 22. So I bring down the 8. 22 is less than my divisor, so I'm good. So now my new problem is how many times will 57 go into 228? It just so happens that 4 times 50 is 200, and 4 times 7 is 28. So 4 times 57 is 228. So magically, you end up with no remainder, and therefore the answer would be 7.4 meters for the width of the rectangle. So we're looking at a word problem here. Brian was tiling a patio. That means he's got a patio floor and he's putting tiles down on it, something like that. So he puts all his tiles down, and he's got an area left over that he wasn't able to tile. That is 3/4 of a yard by 3 yards. So they're asking us to find the area of that leftover part. So I've gone ahead and drawn my rectangle area model. I'm just going to multiply 3/4 times 3. I can do it a couple ways, but if this was each one whole, that would be a third, 3/4, 3/4, and 3/4 this way. So 3 times 3/4. And you could do it by adding them together, or you can just multiply 3 times 3/4. So here I'm showing 3 times 3/4. 3 times 3 is 9. 1 times 4 is 4. So this area will be 9/4. That's an improper fraction. 4 will go into 9 2 times, and there'll be one part left over. So the area of that part is going to be 2 1/4 square yards. Here is how Thinkcentral did it, same way we did it. Just study that further if you need clarification. Same type of problem here, except it's Kobe and he needs to figure out the area and the perimeter of his farm. So first thing you're going to want to do is you're always going to want to draw an area model. The length of the property is 1/15 of a mile, and the width of a property is 3/8 of a mile. So you have an area that is, you're going to measure it in miles. It's going to be square miles. Perimeter is just going to be distance around, adding those up. Let's first look at how you find the area of it. I have 1/15 times 3/8, length times width. Multiply the numerators. This one actually, let's see if we can simplify it first. 3 divided by 3 is 1, and 15 divided by 3 is 5. So you can simplify these fractions before you multiply across. 1 times 1 is 1. 5 times 8 is 40. So the area or space inside his farm is going to be 1/40 square mile. Next I set up my equation or my expression for finding the perimeter. I have 3/8 and 3/8 plus 1/15 and 1/15 because I'm adding all the distances around the shape. 3/8 and 3/8 is 6/8, and 1/15 and 1/15 is 2/15. Notice that these are unlike fractions, so I'm going to need to find a common denominator to add those together. So I went ahead and lined them up vertically so I can find a common denominator. I've done the multiples of 8, 16, 24, 32, 40, 48, 56, 64, 72, and 80. But I'm having a hard time finding a common denominator, so another way to do it, and probably an easier way to do it, is just multiply this by 15 and this by 8, and for sure you'll find a common denominator. So when I do that, I get 90 120ths and 16 120ths. If I add those together, that would give me 106 120ths. So I'm going to simplify that because they both have a common factor of 2. Dividing them both by 2 gives me 53 60ths. So the area, the perimeter of this farm is 53 60th miles. Again, here's how Thinkcentral View Example did it. So you can follow along there. If you need additional clarification, pause the video. Alright, taking a look at the next problem, make sure you unpack it carefully because I see that we're supposed to round the length and width to the nearest half unit first and then solve it. So that's going to make a big difference. So we're going to be finding the area and perimeter, but then it says enter your answer as whole numbers or decimals. So keep that in mind. So when we're dividing or multiplying, we need to either show decimals or whole numbers. We're not going to leave it as fractions. Margot wants new carpet and a new wallpaper border in her bedroom. The room is 6 3/10 yards long and 4 8/9 yards wide. So they're giving us decimals here and fractions here. So we don't want to use fractions because it says they want the answer in decimals. So first thing you're going to want to do is you're going to want to draw a picture of her floor. So for the carpet's going to be that way. So it's 6 3/10 long, 4 8/9 wide. But they asked us to round the length and the width to the nearest half unit. So think about 6 3/10. Is that closer to 6, 6.5, or 7? So 6 3/10 would be, right here. 6 5/10 would be a half. So I'm going to round this number to 6.5. 4 8/9. 4 8/9 on a number line would be over here. So that would definitely be closer to 5. So I'm going to round this number up to 5 because 5 is the closest half. So using those numbers, I redraw my area model showing 5 yards wide and 6.5 yards long. On the area, I multiply 6.5 times 5. I do have 1 decimal place over here, so the way that I do that, I send them on vacation to the island. 1 decimal place goes away, and then I just multiply 65 times 5. 65 times 5 is 325. So next thing I have to remember is bring back that decimal point and put it back in the answer. So the area of her room is 32 5/10 square yards. And here is the Thinkcentral example of how they solved the problem. Alright, going back to the next step, you need to find out the perimeter because you're asking for the border, and that's the distance around the wall. So you have to add up 5, 6 5/10, 5 and 6 5/10. So adding those up, 5 and 5 makes 10, 6.5 and 6.5, or 6 5/10, plus 6 5/10 is 13. So it's 10 plus 13, or 23 linear yards for the perimeter, or for her border. And here is the Thinkcentral solution to the problem. Alright, final question. This has been a long lesson. Laura has a rectangular piece of wood. It's 8 by 3 inches. So always, 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 draw your model when they suggest it. It helps you understand the problem. So when you're unpacking, make sure you're drawing. She wants to cover the top of it. That would be this part, or another word for that would be the area. Cover the area of it with a piece of wood with strips of ribbon that are 1/3 inches wide. What length of ribbon does she need to cover the entire piece of wood on the top? So this is a really difficult problem because this is the hard part right here. You're covering the top, but you're only covering it by strips of ribbon that are only 1/3 inches wide. So what's hard to see is that this is 8 inches wide here, and this is 3 inches, or 8 inches long and 3 inches wide. So if I have a piece of ribbon that's only 1/3 of an inch wide, I'm not going to be able to cover a whole inch. So I'm going to need, let's assume this is 1 inch here. I'm going to need to have a piece of ribbon that's 1/3 of an inch here, another 1/3 of an inch here, and another 1/3 of an inch here. to cover this 1 inch wide piece. I'm going to blow this up larger so you can see what I'm talking about. So I just took off 1 inch of it. I know it says there's 8 inches, but I just took one piece of it. So if that ribbon, let's say it's blue and it's 1/3 of an inch, I'm going to need 3 inches of that 1/3 inch ribbon here, and I'm going to need another 3 inches of that 1/3 ribbon here, and another 3 inches of that 1/3 ribbon here. So together, just to cover this 1 inch of the tabletop, I'm going to need 3, 6, and 9 inches of ribbon. This might give you a better idea of what I'm talking about. So the whole tabletop is 8 inches long and 3 inches wide. So each one of these is an inch. 1 inch, 2 inch, 3 inch, 4, 5, 6, 7, and 8 inches. But inside each of those, I'm going to need 9 inches to cover that 1 inch. And I'm going to need another 9 inches to cover that 1 inch, and another 9 inches to cover that inch, etc., etc. So as I lay my ribbon down on the table, I'm going to see that I will need, for every inch of the tabletop, I'm going to need 9 inches of ribbon to cover 1 inch. So basically it is 9 inches times 8 will give you the answer to this problem. So the easy way to do that is just multiply 9 times 8. So 9 inches of ribbon times 8 inches will give you 72 inches of ribbon total to cover the top. Another way to do it, you could just multiply 8 times 3, so you know you need 24 square inches of ribbon, and if you divide 24 square inches by 1/3 of an inch, you're going to end up with a keep change flip, you're going to end up with 72 total inches of fabric needed to cover the tabletop. But the key there is that understand that each piece of ribbon is only 1/3 of an inch wide, so you will need 3 of those pieces to cover 1 inch of the top. Again, here's Thinkcentral's the way they did it. It's kind of similar. I think I like my picture better because I can understand it more looking at a picture, but study this, it might help you. And that's the end of our lesson. It was a long one. Perimeter and area, Thinkcentral Lesson 8.8. Let us know if you have any questions.